Hello, in this video, let us discuss the MIPS bus architecture. A bus is a group of wires that are conductors through which the address or data or control signals are transmitted. If an address is transmitted, then the bus is an address bus. But if data are transmitted through the bus, then it is called a data bus. If control signals such as read-write memory requests or synchronization signals are transmitted through the bus, then it is called a control bus. All devices are connected to the same address, data, and control buses. The information can be shared between the devices synchronously or asynchronously. If the information shared or transmitted is synchronized with the bus clock, then the bus is called a synchronous bus. Only devices which are faster than this bus clock or bus speed can communicate in this fashion. If the devices are slower than the bus clock speed, then they can communicate using handshake signals. But this method can also be used for high speed devices. Now, let us see how the data is read from a high speed memory in a synchronous bus. In a synchronous bus, all the signals are transmitted based on the clock cycle. So, this is the timing diagram for synchronous memory read. So, in this timing diagram, three clock cycles have been used. This is the leading edge and it is identified from low to high transition. Similarly, this is trailing edge and it is identified from high to low transition. The address is put on the address bus during the clock cycle T1, T2 and T3. You observe that the address is available only at this point of T1 and it is available up to this point in T3. When the address is given to the memory chip, it will not immediately put the data on the data bus. We have to give memory request signal to select the chip. After that, we have to give the read signal. So the memory request and read signals are available from this period in T1 to this period in T3. Now, the data for the given address will be put on the data bus during this clock cycle T3 from this period to this period. During this time, since the read signal is available and memory request signal is also available, the corresponding data will be read from the memory chip and it will be put in the processor. When a low speed memory is to be interfaced with high speed CPU, then asynchronous data transfer method will be used. Now let us see how data is read from a low speed memory using asynchronous bus. Here clock signals are not used. We are using handshake methods. That means we will be using master synchronizing signal and slave synchronizing signals in the handshake method. First, address is placed at any instant of time depending on the requirement. The memory request and read signals are placed after placing the address. See, this line indicates that it is active low signal. That means normally the signal will be high and it will be active when it is going low. So this is activated signal. Activating is also called as asserting. So when the memory request signal is asserted, it will go to low level. Normally it will be high. Similarly, read bar, that is also indicating an active low signal. And we have master synchronizing signal which will be activated after placing the memory request and read signals. Now, this master synchronizing signal will make the memory to put the data on the data bus. During this period, data is available. Since the read signal is active and memory request signal is also active, the data will be read. At the end of the read data, The slave synchronizing signal will be generated. It is also an active low signal. During the high to low edge of the slave synchronizing signal, all the already activated signals will be deasserted. That means they will be deactivated. So, at this point, the master synchronizing signal will be closed. That means deasserted. Similarly, read signal will be closed. Memory request signal will also be deasserted. Now, when the master synchronizing signal is closed, the data put by the memory will also be closed. So, data will not be available after this period. And slave synchronizing signal will be deactivated. That means it will go to its normal state. So, like this, one read cycle is completed by placing the address, putting the memory request and read signals, then giving a master synchronizing signal, then reading the data. After reading the data, slave synchronizing signal will close all the remaining signals, including the address placed on the address bus.